Are those Hubble shots of Mars?
I think they are.
Yeah. I'm astounded that the 2 moons of Mars were discovered from the Earth. They're so
They're
tiny.
little guys, aren't they?
What's that? Oh yeah, they're like
Moons are tiny.
9 and 25 kilometers, which makes them like 5 and 15 miles wide. They are absolutely minuscule.
Yeah.
Absolutely. And they're so close.
The bad frequency.
I
The
think
bad frequency is from Fayetteville, Springdale.
Deimos orbits like 9,000 kilometers above the surface.
Mm-hmm.
And Phobos is like 24,000, something like that. And so Deimos is actually close enough that it's inside the Roche limit. Mars is a tiny little planet, but Deimos is inside the Roche limit, and it's being torn apart. And it actually orbits faster than the planet rotates. So it rises in the east and sets in the west. And it crosses the surface, it crosses the sky 3 times a day, which is absolutely nuts.
Hmm. Okay.
It's not round, so it doesn't have phases like we conventionally think of them.
Right.
We just had my first astronomy for educators class today. We asked them to tell me, look up moon phases on any book or on the web. Tell me what you learned. Nobody learned that the terminator is actually where sunset and sunrise occurs on the moon.
Oh.
Nobody learned that. The other one nobody learned was that, what was the other one? Very common thing. I'm blanking on it now. It'll dawn on me later. But a bunch of just real basic stuff they never learned. They never learned the terminator goes from North Pole to South Pole. Nobody came up with that one.
Mm.
And I was mean to them. I had them predict what the lunar phase is going to look like for the next week.
Wow.
So we'll see how they do next Monday. So there you go.
There you go. I'm always reminded of the video, that little documentary, a Personal Universe or something like that.
Yes.
Harvard grads and professors getting it horribly wrong.
Horribly wrong. I didn't ask them how it worked. I just asked them what they could learn.
Yeah.
They came up with, there are 8 phases.
Okay.
Like, well, sort of. They came up with waxing and waning.
Okay, that's good.
That's good. They came up with that the lunar cycle takes a month, which is good.
Yep.
But the stuff they didn't come up with is amazing. Nobody came up with how lunar phases work.
In the 1960s, 3 Mariner spacecraft flew by Mars and photographed about 10% of the surface. The photographs revealed a cratered landscape much like the moon, waterless and apparently hostile to life. And then in 1975, 2 Viking spacecraft were launched, each of which was programmed to land a robot on the Martian surface. On July 20th, 1976, flight controllers ordered the lander to separate from the orbiter.
Minus 105. 23 Gs. 2,600 feet, 188 feet per second. So the engine 0.6 Gs. 20 feet per 366 feet, 73 feet per second. ACS is close to vertical.
So we're coming down, straight down.
Nav is green for touchdown. ACS is green, 1.5 degrees per second max, 0.2 Gs. 8 feet per second. Touchdown, we have touchdown. Digital zone.
Yes, we have a touchdown time of 12 hours, 12 minutes, 07.1 seconds.
I'm assuming that we must be sitting right on the X. So that's the smooth area. So everybody just did fabulous and couldn't be more pleased. Thank you.
25 seconds after landing, one of the two cameras was initiated and scanned the first picture of the Martian surface.
Oh, look at the beautiful rock. Fantastic. And all of a sudden, we were looking at the surface of Mars, and it was clear, it wasn't dusty, it was sharp, with the dust and small pebbles in the footpad. It was just, it was really a miracle.
And there we go.
And there we are. Well, let's play this, which I always like to play.
My brother.
How's that? So,
That's awesome.
hey everybody, this is Scott Roberts here with Dr. Daniel Barth and Annie Scarborough, and we're here with the 22nd episode of How Do You Know? Before we get started, let's find out what's going on in the Explore Alliance with Annie.
Well, I wanted to come on here, and last Wednesday, I very quickly announced some winners for the astrophotography contest, and I've got to get emails out to those people. But I did want to tell Dr. Barth that we did find a winner for his 25th episode.
20th.
And 20th episode.
Not to the
Sorry.
25th yet.
We just talked about another 25th episode. So I'm like, okay, all these numbers are in our brain. But Tom Dastrup is the winner. We had four people reach out and answer the question, and everybody answered it correctly. So then everybody just kind of went in a number generator, and so he's the one that won, and so he'll get that 20 millimeter 52-degree eyepiece on there. So but after that, I wanted to kind of highlight, it's kind of funny that you guys showed a Mars video, because I hadn't really told you what I wanted to show today, because we haven't really highlighted very much at Explore Alliance. But one of the great benefits of Explore Alliance is you get our our Skies Up magazine, and it it has those contest winners that do our photography contest, but it also has some other amazing articles in it. And so I was going to show how everybody could get on there on the website. If you're not a member, we actually have it on our website. So if you go Explore Alliance and then go Skies Up Global Astronomy Magazine, it's right here. And we have all of our older magazines.
Issues?
Yeah, issues. Thank you. My brain is not. I should have taken that coffee he offered me earlier today. Yeah, issues. And so, you just click on them, they'll open right up. And then you can scroll through them. But this episode, this issue that we just did, has a great article on the Mars landing that we just recently did. And so, but there's amazing articles in here. In fact, I just spent the last 30 minutes just sitting and reading this a while ago. So Scott, that's what I was doing while I was working.
Not what you were doing. I see.
So, because it's so intriguing. Once you get
put it together,
reading,
I guess it's company stuff, right?
Yeah. Well, once you get
Somehow.
to reading, once you start reading it, it's like you just continue on.
Can't stop. Yeah.
Yeah. So there's some really great articles in here, and then I think if you keep, this is 80 pages. So, but if you keep going, you can actually, see, it's 80 pages. You can actually find, I was going to see if I could find it. Oh, here's our winners. So this is, this was our deep sky winners that we just did recently. Well, it's actually been a couple of, I think it's been 3.
Yeah, that was
3.
yeah.
So, so what happens is if you enter and it doesn't matter if you win or not, we put you into our Skies Up magazine. So, and then you'll get, and then as a member, you also get a subscription to that. So sent to you. So, you know, it's a great resource for just learning things and seeing what's going on in the world of astronomy and stuff like that. So, but I just wanted to highlight that for a minute. So, because we don't hardly ever talk about it. And then I was like, wait a
Skies
minute.
Up. We should talk about it all the time.
Skies Up.
We'll start talking about it more. It's a great,
Skies Up.
it's a free publication. It's
Yep.
global. Okay. The editors are David Levy and also cosmologist Marcelo Souza out of Brazil. And we get contributors from all over the world to that magazine. So it is truly global and available for free download. And we will have an app in the Apple Store pretty soon, and also on the Android store, so that you can
that's
watch it.
awesome.
Yeah,
That's
so,
amazing. That's
yeah.
amazing. Yep. So
It's coming up.
that's pretty much it. You know, we still have those pre-orders for the Binoviewers, and I think we've got 4 more etched 152. So if you want those, reach out to me. And then of course, if you're wanting to know about membership, just email me or call me and I'll
All right.
give y'all the download on it. So
Thanks, Annie.
so thank you.
Okay. So we'll get to our episode here. And Daniel, this story about the search for life on Mars is very intriguing to me. And, when you kind of see all of this unravel,
That's a good one.
I don't know. I have a lot of questions about it, so I have a lot of questions. So, and why we didn't do this and why we don't do that, so there's things I would like to know more about what's going on with this, with the Viking Lander and the Levin experiments. So, but I'll let you take it from here.
Well, thank you. We're going to dive in. And I've mentioned this before. When people say, hey, Doc, do you think there's life on Mars? It's one of those things, and I've said before, it's like a week's answer or none. So we're getting the long version. But before we launch into that, I just wanted to say we thank our audience. We've kind of passed a milestone. The Astronomy for Educators book, we now have more than 6,000 teachers.
Wow.
And that means we're reaching somewhere between 200,000 and 250,000 students worldwide.
Awesome.
And that's just in this last calendar year. Since last October, we started to take off and go viral, so to speak. So it's terrific. It's kind of scary. Now, I've been in the classroom, Scott, 42 years between high school and university work. 42 years, and I've had about 7,000 students come through my classroom.
Wow.
And this book is now reaching more than 200,000 worldwide. It's
That's
so
cool.
exciting.
It's cool.
It's so exciting. And this morning, before my first class, I finished the first draft of the new book, Star Mentor. So managed to get 100,000 words in about 175 illustrations done in 5 weeks.
In 5 weeks. Wow.
Boom, cranking it out. I
That's
love it when my students come in,
amazing.
but you want us to write 2 pages a week? You're mean. It's too much.
You have no
And
sympathy for them.
And I laugh at them. So no, I got that done. And as I said, when they talked to me last October, they said, how much time do you need? And I said, well, it's October now. Let's say Christmas of 21. This was in October of 20. And then they got back a hold of me in March and they said, well, we're really seriously thinking about it. How much time do you think you need now? And I said, well, Christmas of 21. And then they finally said, we want the book. Go ahead and write it for us. It's the end of July. well, how much time you need? I said, Christmas of 21. And they said, no, really. We need this much. We need 100,000 words. And I said, no, Christmas of 21. Really? I want to finish it before classes start. And there was eye rolling and sighing. And yeah, okay. So I got it done about an hour before my first class started this semester. So I made my goal. Boom. So that's very exciting.
That's just going to make them ask for more, right? So,
well, yeah,
now that they know you can
for a
crank it
job
out.
well done is another job, isn't it? In your company too, I suspect. Anyway, so back to Viking. We've talked about the ideas of what space exploration was like in the 1960s and 70s. And we saw that lovely video with the clutch cargo style animation, little paper things being almost like Monty Python did it. And you saw those views, those very blurry views. That was the best shots of Mars we had from the Pioneer orbiters. You realize, Scott, those orbiter lander combinations went into orbit, stayed in orbit for about a month, photographing the planet because we didn't know where to land. We had to pick our landing spots after we got there.
Yeah.
It's like going to a big football game. Can we put in a parking spot? We're going to have to cruise around a little. So we cruised around for a month or so looking for a parking spot, and we finally found one. And that big rock that you saw in the background looks like it's about the size of a school desk. They called that Big Joe. If the lander had landed on that, it would have tipped over and crashed.
And that would have been it.
That would have been it. And that was the nice one. That was Chrysoplanetia. That was the smooth spot. And the Utopia Planitia was rockier. And they landed in a field of boulders. It was crazy. And this thing couldn't move. It wasn't a rover. It wasn't parachuting down and sky craning. It just had a rocket motor. It came down. It turned on the rocket motor very much like the LEM. And it touched down, shut off the motor, and that's where you're going to stay. So that thing hasn't moved from that day to this. We landed on July 20th, 1976, 7 years to the day that Apollo landed. That was not the plan. They wanted to land on July 4th, 1776, which was the bicentennial. But they couldn't find they couldn't find a parking space. They couldn't find a landing spot that quickly. And so the landing was delayed, and the 7 years after Apollo was kind of a happy coincidence. So anyway, let's talk about the landers. And it's so typical today, I have to stop myself, because when you talk about exploration on Mars, what's the word that comes out of your mouth? Rover. Because we've been roving on Mars since 1996 with Pathfinder. And Spirit, Opportunity, and now Curiosity and Perseverance. And so we've got this fleet of rovers on Mars. And we tend to think rover, drive here, drive there, drill, go over there, look at that rock. Viking was none of that. Viking was a land, and basically you land, you touch down, you can reach out and scratch the soil, and that's about all it could do. Now, they started planning this in early to mid 1960s. They were planning it as they were developing the Apollo program. The landing program, it was originally supposed to be called Pioneer. It was supposed to be one much bigger lander with a lot more science stuff. And they were going to launch it on a Saturn V. But then with the Mariner program, what started happening, or I think it wasn't Pioneer, it was Voyager was the original name for it. Doesn't matter. Anyway, with the Mariner program, they started losing spacecraft going to Mars. The Russians tried 9 spacecraft that all failed to get to Mars. Some of them got very close, but they all failed. And so NASA became very sensitive to mission failure, and they decided they didn't want to have one big science package. So they decided they would have 2. Each would be launched on a smaller Titan, basically an ICBM, and a Titan III. And they went ahead and they did 2 identical spacecraft. And because they were scaled down, each lander had 3 experiments to look for life and a gas chromatograph mass spectrometer to look at the elements in the soil. So you're going to take a physical look at the soil. They had little weather instruments. They could tell temperature, air pressure. I don't think they had an anemometer for wind speed, but they had temperature and air pressure. They had cameras, but the main thing they had was 3 experiments to look for life. Now, I'm going to go ahead and share a photograph. This is not from Mars, and I'm sure all of our viewers, or most of them, will recognize this. This is
Yes, I had
a
one.
Tonka toy digger excavator.
I had one.
If you were a kid in the 60s, the 70s, the 80s, and maybe into the 90s, you probably had one of these. They still make them, but they're not all steel like they were back then.
Hmm.
But this is basically designed for the rover. The arm would reach out and could scoop into the soil. It could dig 5, maybe 8 centimeters deep, a couple of inches, and it could reach out about 3 feet, and it could swing a few degrees either way from center, and it could scoop up soil. The soil, Scott, would have been scooped up right off the very top. They were looking for areas that were not very rocky. They wanted soil, and they were scooping it up, bringing it into the rover, dumping it into a funnel. Then there was a mechanical system, basically a little spice grinder, would grind the soil, partition it out, and from there it would be mechanically delivered to various science experiments. So this was the Viking Lander. It was essentially, it was a Tonka-style digger excavator, which is very cool, and they did amazing things with it. So these 4 experiments, we're going to take a look at the way this was designed, and we're going to take a look and focus really on the 3 major Seek for Life experiments. Now, each of these experiments was designed by a different person. The head scientist, who NASA refers to as the principal investigator, or the PI. And the principal investigator, of course, put together their team, and they would submit a proposal. We want to put this on your nice shiny lander, and here's what it's going to do. Here's how it's going to look for life. NASA had something like 170 proposals. They selected 3. And obviously, they're picking the 3 that they think will have the best chance of finding, detecting microbial life on Mars if it was there. By this time, we knew pretty well what the surface was like: dry, rocky, no open water, very low air pressure, very cold. We knew the atmosphere was primarily CO2, little to no oxygen, little to no water vapor. So we didn't expect to find any macroscopic life. Nobody was expecting lichens or plants or little cockroaches or anything like that. What we were looking for was microbial life. And the analog for that is pretty clear. Places like the Mojave Desert, the Atacama Desert, the dry valleys in Antarctica, where not much other than microbial life is there because the water is very, very scarce. So let's take a look at the 3 big experiments. The first one was called Gas Exchange. And this one was designed to look for purely microbial life. The experiment was conducted in the dark. There was no light. So photosynthetic life would not be detected. What they did is they took some dry Martian soil, they put it in the bottom of the chamber, and then they exposed it to, first of all, humidity. They injected some water vapor, and then they added some drops of what they called chicken soup. Today, we'd probably call it Gatorade, which was actually probably closer to what it really was, because it had water, had sugars of various kinds of sugars. It had nutrients, it had vitamins, it had amino acids, it had essential salts, not just sodium, but potassium and magnesium and zinc and other things like that. They basically went through and said, if you're going to make a grows everything medium liquid where any bacteria on Earth would love this and would flourish, what would you have in there? And so they made this chicken soup mixture, and they found some interesting things. The first thing they found is as soon as they humidified the soil, they got oxygen. So they're adding water vapor and the soil starts emitting oxygen. It also emits carbon monoxide. And basically, they did something interesting, Scott. They had this idea, and it was quite clever. They said, well, how do you know if something is organic or inorganic? In other words, is it just chemistry or is it biology? And the answer they came up with still applies today. They said, well, you know what? We'll heat it. We'll heat it up to about 300 Fahrenheit. If it's based on biology, it's going to die, especially if it's a Martian organism adapted to this frigid cold weather. You know, there are fleas in Antarctica that live on penguins.
Wow.
The fleas are so well adapted to the cold that if you hold one in the palm of your hand, the flea will die from the heat. Okay.
Wow.
So they kind of had this idea, well, if these organisms are adapted to life on Mars, where it's very, very cold, if we heat it to 300 degrees, we're going to kill it. Basically, that's also how we autoclave and sterilize everything on Earth. You go to the dentist, you go to the doctor, the instruments are sterile, they're in a little package. They've been heated to 300 Fahrenheit, and that's how we sterilize them. What they found was this humidity-oxygen reaction happened whether the soil was hot or cold, didn't change. That screams, this is chemistry, not biology. Well, they said, well, why is it doing this? And they came up with this idea that the super drying and then exposing to ultraviolet and other radiation could create what we call peroxides. The most common peroxide most people know is hydrogen peroxide. If it's a little stronger, it dyes your hair, it bleaches your hair. If it's a little less strong, you use it as mouthwash, put it on a cut, right? Peroxides release oxygen when they react. And so they did this gas exchange experiment 9 times with the first lander, 9 times with the second lander, which were basically on the opposite sides of Mars. They found the same thing every time. They were getting oxygen, but they were not getting anything that indicated a biological product. So the Gas X experiment basically said, I do not detect life. Okay, fair enough. Well, we get to the second experiment. And this experiment was designed by a fellow named Norman Horowitz. He was a NASA insider. Dr. Horowitz had this really cool idea. We'll take the Martian soil. We will not put liquid on it because the organisms there, like if they're there, they gotta like really dry, arid conditions. So we won't try adding liquid. That might kill them. So what he said is, I know, what we'll do is we'll take the soil, we'll grind it up, then we'll flush it with pure nitrogen, and then we'll put it under a vacuum, pump all the atmosphere out we can, and then we'll reintroduce carbon dioxide and carbon monoxide. But instead of being CO2 and CO labeled with, or they're not made with carbon-12, the normal everyday non-radioactive carbon, they use carbon-13, which is a radioactive isotope. It's very rare in nature. And so they flooded the chambers with this radio-tagged gas with the idea, if there's microbes, their only carbon source is going to be CO2 in the atmosphere. And there are plenty of organisms that live that way on Earth. And they would go ahead and take up this CO2 and they would incorporate it. They would make, you know, things like sugars, like cellulose, like cell wall material. The whole cellular mechanism is made out of carbon. But they would be consuming and manufacturing their body materials with this radioactive carbon. Well, what we do after that is we go ahead and heat it. But this time we heat it to 635 centigrade. That's almost 1200 Fahrenheit. Horowitz's idea was any biological material is going to be vaporized. And when it's vaporized, these, if they're there, right, these radio-labeled materials, sugars, celluloses, whatever, are going to be turned back into carbon dioxide. So we let them feed for a while, we get rid of the radioactive gas, we heat the heck out of it, we see what comes off. And they originally thought, ooh, this looks good. We're getting a reaction. We're seeing some radio-tagged carbon being released when the soil gets heated. Well, they ran this experiment 18 times, and the more they looked at it, they're like, yeah. It was within that error limit. We've talked about this idea before, Scott. If you have an experiment which it's accurate to plus or minus 2%, and you get an answer that's 2 to 3%, that's really close. It's close enough that it's as likely to be zero as positive.
Zero, right.
So they said, you know what? This is statistically not significant enough to say yes, so we have to say no.
Okay.
So we've had these 2 experiments, and one doesn't detect anything. The other maybe detects something, but it's not really getting a good result. So they said labeled the pyrolytic release did not detect life. Now we come to the 3rd experiment. Third experiment is called labeled release, and it was designed by Dr. Gilbert Levin and Dr. Patricia Straight. Dr. Straight died in October of 2020. Dr. Levin sadly died a month ago. Just a month ago, Scott, as you said before the program, if we had done this in May, we may have been able to have him on, which would have been,
that would have been amazing.
It would have been wonderful. I would have gotten to meet one of my heroes. But Dr. Levin, wherever you are,
Hope you're watching.
Yeah, I hope you're watching. So this labeled release used something called radiospectrometry microbial metabolism. I know that's hard to say, RSSMM. Levin developed it with Dr. Straight and Dr. Wolf Vishniak. Dr. Vishniak died in the 70s experimenting. He was lost in a crevasse in one of the dry valleys in Antarctica and perished.
Oh, wow.
Dr. Levin and Dr. Straight survived until just months ago, literally. But his experiment...
This experiment was one of how many experiments was submitted?
Oh, no. 170, give or take.
170. So these things must have been like totally scrutinized because we're going to Mars, right? For the first time.
Oh yeah, we're paying $1 billion per mission. We spent $2 billion, so we're spending $1 billion in 1976.
These experiments.
That's way more money than.
Oh yeah.
It makes you look at the rovers and say, "Wow, really cost effective."
Yeah.
NASA's not wasting money, friends. But it was the first time. Right? It was the first time.
First time.
Makes me wonder what the Wright brothers plane costs in today's money. Cost per technology achievement was outrageous, but it was the first time. So Dr. Levin's experiment is also not designed to look for photosynthesis. Dr. Horowitz's was. And his idea was we prepare the sample, and then we've got a chicken soup. But this chicken soup is radio labeled. Like the pyrolytic release experiment, this chicken soup is radio labeled. And what he does is he puts 1 drop in the center of the sample. And his idea is the water is going to spread out slowly so that some areas in the center are quite wet. Then there's a gradient. It gets drier and drier and drier until the edge of the experiment is barely wet at all. So he says this way we'll have a variety of conditions. And if there's an exact ratio that the organism likes, it'll probably find it, because remember, the soil sample was ground and mixed and pulverized before it was put in. So after watching this, and he let it sit there for a period of days, his idea was, if you're taking in liquid nutrients, you're doing what all biological organisms on Earth do. You're either excreting carbon dioxide or methane, right? Bacterial life, I mean, yeast, right? Make bread, wine, beer, they bubble off CO2. And there are various methanogenic bacteria, they're the minority group, but they bubble off methane. But all of the anaerobes, the organisms that live without oxygen terrestrially, they put out CO2 or CH4, right? So we're talking about carbon dioxide or methane. But either way, Dr. Levin's idea is, if they're consuming these materials and evacuating waste gases, the waste gases will be radio tagged.
Okay.
So we put the soil in, we evacuate all the air, we put in some clean air that's filtered, we put in a drop of this radio labeled solution, and we have a Geiger counter. And we watch the air above the soil sample, right? Now, Geiger counters are directional, they have a window. So we don't set it this way looking at the soil sample, we turn it 90 degrees looking across the chamber.
Okay.
The only way it's going to get counts is if material is evolving off of the soil. Well, what they found, and I'm going to show everybody another document, and this one, Dr. Levin cites this as perhaps the most significant document in the history of science. What you're seeing here is a Geiger counter plot, and you're seeing time across the bottom.
Okay.
And what you see is the flat line, and then you see they add the liquid nutrient, and after that, immediately radioactive counts.
Off the chart.
Right, and this is a logarithmic scale, mind you. So their counts went from background, which is about 20 or 30, to about 11,000.
Wow.
Okay, and tonight, July 30th, 1976, 7:30 p.m. Pacific Daylight Time, Sol 10, and you can see there that everybody, Pat Straight has signed it, Gilbert Levin has signed it, and a bunch of scientists are there. Norman Horowitz is not one of them, at least they don't see his signature there, but they signed it and they said, wow, you did, Dr. Levin, you found life on Mars. Now,
what happened?
Well, we'll show you one other piece of data, and I'll share this screen also. This comes out later. And what we're looking here is Dr. Levin did a control. He took a soil sample and heated it to 300 Fahrenheit, 160 C,
Okay.
and he put his nutrient material on it, and he got nothing. It flatlines. On the other hand, the cycle 1 you see there, the counts go up to about 11,000. This is in the Chrysoplanitia area. In Utopia planitia, they got about 30% more. The soil was more active. What's more, you see that active count where it goes and it stabilizes at about 10,000 counts per minute? After it had been running like that and stayed stable for several days, he heated it and it died. When it was running well and he heated it, it flatlined.
All right.
Now, I'm sure a number of our viewers know about basic inorganic chemistry. If you have a chemistry reaction, baking soda and vinegar, right?
Right.
If you put it in cold, you get a slow reaction. If it's at room temperature, it's a little faster. If you boil the vinegar first and pour it on the baking soda,
Oh
it
my
reacts
God.
like crazy.
I'm like crazy.
The hotter it is, the faster it goes. Biological chemistry is based on protein-based enzymes. The enzymes are not heat stable. They're designed to operate within a very narrow temperature range and very narrow pH range as well, usually. And if you tamper with the conditions very much, life dies. and you can't uncook the egg. You can't cool it off and reassemble those proteins. They're denatured, they're destroyed. And what Dr. Levin found was that, gee, if you put this nutrient, this radio-labeled nutrient solution on the soil, something starts happening. It produces evolved gases that are radio tagged, which indicates metabolism. If you heat the soil first, nothing happens. If it's cooking along and producing gas and you heat it, the reaction falls to zero and will not revive. So that's Dr. Levin's experiment. 18 times, 2 different sides of Mars, the same result, except that in Utopia, which is supposed
Viking
to
1,
be
Viking 2 are coming
Right.
in the same thing.
Chrysoplanitia is supposed to be a river delta. Utopia planitia is supposed to be a seafloor. And the seafloor showed more, I'm just going to say activity. I'm not even going to say biological, but it showed more activity. Now, interestingly, when we look at this and we take a look at this and we go, okay, we've got this reaction. If we heat the soil first, it doesn't happen. If we put the stuff on just regular soil, it happens. If we heat it, the reaction stops. I won't say dies, right? I'm not going to pollute the conversation here, but the reaction stops and we cannot restart it. Gee, Cock Robin, you shot the sparrow with your arrow. Can you make it live and fly again? No, you can't. We've all heard that fairy tale. And basically, I want to note here, Scott, that before Viking launched, an international community of scientists got together and they said, all right, what will a successful detection of life on Mars look like?
Yeah.
And basically, they all agreed the reaction should proceed at ambient temperatures. The reaction should show sensitivity to changing biological factors, the amount of nutrients, the amount of light, and the reaction should be sterilized by heat. It should stop and it should not revive. It's possible, I suppose, you can kill a reaction that's inorganic and it will start up again. Dr. Levin's experiment met every single criteria established by international committees of scientists from around the world for a successful detection of life on Mars. Every single one.
Okay.
NASA's official line today is the Viking found no life on Mars. There is no life on Mars. Mars is a dead planet. And until very recently, the official line was no water, no life. Mars is always dry now. It's always been dry. And it could never have had life. That was the answer through until 2006.
Wow.
The answer was Mars has never had water. Mars could not have life because there's never been water there. And we know that Spirit and Opportunity changed all that. 2006, Dr. Stephen Squires, who was the principal investigator for Spirit and Opportunity, got on television and announced to the world in an internationally televised press conference that ancient Mars was, quote, warm, wet, and habitable. They found sulfates, they found phosphates, they found carbonates, all of which require water. They found hematites, they found clay deposits, and they said all the rocks show that they've been modified by flowing water, and they wet chemistry, and they said Mars was warm, wet, and habitable in the ancient past, which kind of shot the dry Mars hypothesis in the head.
Right.
Interestingly, nobody at NASA said, we now realize dry Mars was wrong. There was no, Galileo has a press conference and said Aristotle is wrong. Sorry, we have a new theory now and here's how we know. Nobody said the old theory is dead. They just sort of said, oh, look at what we found, shiny, shiny. They never went back and put that result in perspective with previous official positions and interpretations of data. There were, in 2002, there was a guy who was still saying, this is a NASA scientist. Well, the rivers on Mars aren't rivers. It wasn't water. It was liquid carbon dioxide. This was an official NASA scientist. And of course, liquid CO2 requires a pressure of about 4 atmospheres. Mars never had that much atmosphere. The rivers had to be water. They couldn't be anything else. Lava doesn't make river deltas. Couldn't be rills. And so the official response was led by the guy who did the pyrolytic release experiment. The guy was looking for photosynthetic life, Norman Horowitz. And he says, well, the gas chromatograph isn't giving us a good answer. By the way, the peroxides were corroding the titanium or the platinum electrodes in that experiment. It was shot from the very go. It gave no good results because the instrument was destroyed by the peroxides in the soil. Then he said, oh, they didn't know that then. They didn't know that gave no result at all. The 3 experiments, one gave a definitely not, one gave a probably 0. Then the third one gave the absolutely hallelujah, we found it. Dr. Horowitz pushed NASA to the no water, no life protocol. He said, Levin's experiment must be false. After all, my experiment, this isn't said, of course, my experiment didn't detect life. His has to be wrong. Do we hear the sour grapes fox here? Them grapes is probably sour anyways. Do we hear the old Brer Fox story? So he says no, and NASA made no water, no life the official position because in fact, Viking found no water in the soil, none, 0. It also dug about 5 centimeters deep. Famously, the Phoenix Lander at the Martian poles dug 15 centimeters deep and found layers of ice. It's quite likely that if Viking had been able to dig, say, 0.5 meter deep at Utopia Planitia or Chrysoplanitia, it may have found water deposits, frozen water. It never dug there. We won't know until we go there. So, yes, the surface soils are going to be absolutely dehydrated. Solar radiation, the low air pressure, no water vapor in the air, so the osmotic pressure, everything is going to drive the water out of the upper soils, absolutely. And he said, no water, no life. Now, Dr. Levin, very upset by this result, he actually left NASA over this, went and founded his own company. And
Now,
go ahead.
This situation that happened, why Levin leaves, but why did he leave? I mean, was he just short fuse? What was the, why didn't he stick it out? And
I suppose when the official line becomes, you screwed up.
yeah,
The other people got the right answer. That means you weren't just different, you were wrong. Your experiment was a failure. The no answers were correct. Your experiment gave a yes answer. It was broken. It was defective. It didn't work. And keep in mind, Levin has spent probably a decade working on this darn thing.
yeah.
Tens of thousands of man hours. He and Dr. Straight, Patricia Straight, work on this. And they're basically being told, kids, you screwed up. Your experiment was broken. It never worked from the start. Your results are bogus. They don't say what they seem to say. Yes, you made all the criteria, but it's a wrong answer because no water, no life. Sorry, you lose. Not even an honorable mention for most interesting project at the science fair. You screwed it up. You screwed the pooch. You spent all our money and you got a result that was demonstrably false because it can't be true. Now, that's a circular argument. And that really pissed Dr. Levin off. He said, you know, prove to me, show me where my experiment screwed up. Because it did, because there's no water, so there can't be life, so this must be wrong. And the circular argument continues. As Cardinal Bellarmine said, I see, but I don't believe it. Things orbiting Jupiter, I don't believe it.
But they see it.
They see it. They saw the results. I mean, it's public data. They saw the results. Try to find that data on the NASA website today. Good luck to you. It's public domain, but go try to find it. I think you'd have to go dig through file cabinets at JPL to find that. Maybe.
Yeah, I mean, you would have thought it would have been huge headlines around the world.
Well, it was originally, but then it was shut down. By the way, folks, if you're interested, the book is called Mars, a Living Planet. And this is by Gilbert Levin, Patricia Straight, and their helper writer, Barry D. Gregorio. So this is an older book. Trying to look for a publication date, 1997. So you might have to look for this bad boy on eBay.
No, it's on Amazon.
Is it on Amazon?
Yeah, let me see if I can get a shorter link to it.
Good.
No, I posted the link in chat. But
hey, great news. So basically everybody says, you know, sorry, Gil, you screwed the pooch. Your experiment didn't work. Well, what does any reliable experimenter do? And Levin argued for this and was told no. He said, let's go ahead and try it again. Well, obviously you can't send it to Mars, but he said, let's take it out to the Mojave. We're at JPL. It's only an hour or two away. And they said, no, we're not doing it. We're not spending a penny. And to Dr. Levin, and he spoke about this many times over the years, he said, basically at that point, you're just saying, I don't like the results, so I'm not going to repeat it. And to him, this smacked of, I might be wrong, so I'm not going to look. See no evil? So he did it himself. He took over $100,000 of his own money, and this is back in the late 70s, which is a pile of cash at the time. Several $1 million, I would think. And he rebuilt both the pyrolytic release and the labeled release experiment. So he rebuilt Horowitz's experiment and his own experiment to NASA protocols, very expensive. You can't just do this out of Tinker Toys and Erector set stuff. He took it out to the Mojave. He placed it on the ground. A rover-like mechanism scoops some soil out of the Mojave, separates it out, does the same grind and process thing, and he tests the soil in his experiment and in Dr. Horowitz's experiment. And Dr. Horowitz's experiment says soil in the Mojave is lifeless. And of course, the labeled release experiment says soil in the Mojave has microorganisms, which of course you can put the sandy soil underneath the microscope and you can find the microorganisms there. He subsequently did some tests and he said, all right, how much life needs to be present for a successful detection? His experiment would detect on the range of 1,000 microbes per gram of soil. The pyrolytic release needed something like 500,000 organisms per gram of soil. And if you go out to your garden and you dig up a gram of soil, Scott, you've likely got some billions of organisms.
Oh, yeah.
Right? The soil is full of microbial life. But his experiment detects nearly sterile soils. The pyrolytic release experiment does not. And he takes these results public, which is shaming NASA, which is making him no friends. But he's like, look, you guys are, where's my shiny Nobel Prize? Where's my accolades? Where's my shot like Carl Sagan on the Today Show and on Johnny Carson? And I've discovered life on Mars, damn it. And the answer from NASA and Horowitz et al., the Mojave is warm and Mars is very cold. So it's not the same. We're not going to accept that result. So he takes another pot of money and he builds it again. This time, he takes it to the Allen Hills valleys, the dry valleys in the center of Antarctica. These are high mountain valleys. These places average minus 50 Celsius year round. They're right in the center of Antarctica. They're underneath the ozone hole. They get way more hard radiation than you and I would be able to deal with. They get a couple of centimeters of snow a century. They are by far, the Atacama Desert in Chile is much more hospitable to life than the Antarctic dry valleys. They are horrible places. And he took the experiment there. Once again, his experiment detects life. Horowitz's experiment does not. We now know that across the Antarctic dry valleys, there is what they call a biotic crust on every piece of rock there. And the rocks have a very thin crust, microns thick. That's a layer of, it's a organic varnish, which protects them from the environment and somewhat from the radiation. Much of the organisms are algae, right? Bacteria and fungi living in symbiotic relationship. They live down in the cracks in granitic rock. They live down preferentially in quartz vein cracks where some light can penetrate. UV light gets through and it basically melts the ice that's there, a few molecules at a time. These organisms, Scott, literally live a few chemical reactions at a time. No idea what their life cycle is. It may well be decades, centuries. It is the slowest biotic system on the surface of the earth. And Dr. Levin's experiment produces positive results. Of course, his experiment is something like 100,000 times more sensitive to organic life than Dr. Horowitz's experiment.
Why do you think NASA picked such hugely different, precision
They
or
were
sensitivity?
looking for experiments. They weren't necessarily looking for sensitivity. They were looking for success or failure. And Dr. Horowitz's experiment was looking for photosynthetic life, which Levin's did not.
Mm-hmm.
The gas exchange did not. So his experiment was unique. The gas exchange, they all made sense, but we'd never been to Mars. We'd never landed there. We'd never seen the soil. We didn't have good pictures of a place to land. You have to realize how little we knew about Mars in 1976.
Sure.
We had the Mariner photos and that's it. We didn't have Hubble photos. That's pre-Hubble.
Oh, of course.
So we had crappy photos and that was it. We had photos that were not much better than what Percival Lowell took in 1913. So we knew nothing. And so these three experiments all detected life in the soil on Earth. Levin was the only one who was really concerned about very low levels of biota in the soil. The other two weren't thinking, it's clear they weren't thinking in that direction. So the no water, no life has since gone out the window. We know we found water on Mars in abundance. There was an article just today in my news feed that scientists in Germany had been looking at some old, we're talking 19th and 18th century results, where people looked at hematites and said, oh, there's a couple different kinds, and some of them have water available in them. This could be why Mars is red. And these results were poo-pooed by early X-ray diffraction crystallography. They're looking at them again and finding the old results were correct. We now think there could be a lot of water locked in the soil of Mars, not just in the frozen layers underneath the soil. That was today. That was today's news release. Water on Mars is in abundance. You can, many places you can dig a foot down and find ice, many places on Mars. NASA declared Mars was warm, wet, and habitable in the ancient past in 2006, and I asked the same question I asked last week. Scott, if it's hard to sterilize a planet, how hard is it to absolutely dehydrate a planet? To take all the water that was there and drive it off the planet?
All of it?
All of it. Because remember,
It
we
would be
have
very
microbes
difficult.
living 10 kilometers deep that are very happy. Thank you very much.
Right.
We have organisms that live in subglacial lakes that have never seen the sun for tens of millions of years. They're fine. Thank you very much. We have organisms that live near hydrothermal vents 7 miles below the surface of the sea. They're fine. No oxygen, no sunlight. They're fine. Thank you very much. Basically, anywhere on Earth that there is water available in any trace amount, there is life. 100% true. There, we know of a lot more extremophiles today than we knew of in 1976.
Right.
NASA has never in 45 years re-examined their stance in the work of Dr. Levin. They have doubled down, and if you look today, NASA says nothing from Viking detected showed any sign of life. They just basically said, it's a long time ago, let's hope it wasn't true, and nobody remembers, and all the people from then are dead now. And they basically say none of the Viking experiments detected life, which is not true. Now, you can argue that the results weren't valid, but you cannot argue that nothing detected biotic activity. It did. NASA's official stance today is still Mars is lifeless. I disagree. I'm not a kook. I'm not the intellectual version of an extremophile. I'm not a conspiracy theorist. I am a dedicated scientist. My research work before I went into education was in immunology and molecular genetics. I worked at Caltech. I was a research staff member, very junior, private flunky grade, but I was a research staff member at Caltech. I did research at Illinois State. I did research for the US government, various agencies in molecular biology. I'm not an idiot or a dilettante on these topics. My life passion is astronomy, and I think NASA is wrong. I think Dr. Levin was right. In the 45 years since, no NASA mission has ever looked for evidence of current life. None of the rovers have been equipped to look for biologic activity of any kind whatsoever. Now, we've looked at geochemistry. Is it important? Yes, of course it is. We found evidence of water. They had to eat that. They were forced to back it up and say, they didn't actually say dry Mars is wrong. We were wrong. What they did is say, look, we found water on Mars. They never said our stance for the past 75 years was incorrect. They just said, look, new discovery, and
Water.
move on. No, don't look behind. Something might be gaining on you. And in the years since, the Sojourner rover, and we had Spirit, we had Opportunity, we had Curiosity, we had Perseverance, and none of them are set up to look for life. They are set up to look for evidence of past life, geochemical evidence of past life. They are not there looking for fossils. The current rover, the Perseverance rover, is gathering samples. Of course, you got to ask yourself, if you stuff something in a test tube and cork it in the dark for a couple, 3 years, is anything going to be alive when it gets here? Still, if there are cells in any of the samples that Perseverance is collecting, I would be willing to bet those dead cells would still be detectable in the sample data.
Mhm.
But I think really, truly, seriously, the only way we're ever going to get a genuine answer to Dr. Levin's question is we're going to have boots on the ground. As we mentioned before we were talking on the show today, I don't believe the United States government or any democratic government on the earth today is going to get to Mars. Land boots on the ground, I don't believe it. SpaceX said today they think they can put people on NASA, people on the moon before NASA. And NASA plans to do it in 2024. And you know, when NASA says, oh, we're going to do something by this date, that's kind of like saying, can we go to McDonald's? Yeah, we'll see. Right? And mom and dad say, yeah, we'll see. I'm sure we will sometime. Oh, that doesn't mean no. NASA's deadlines have a way of just being ridiculously optimistic. SpaceX says they can get there first. The first men on the moon, those missions were driven by military and political expedience. If you're a fan of 50s science fiction, you may have seen the show Destination Moon. And they made clear, gee, we have to get to the moon first because the moon could be an unassailable base for nuclear weapons that could dominate the Earth. It's still true today. Oh, we have a treaty, but we know what treaties are worth, especially when the other people can't get to you. So they said, no, there's this political necessity. We're in the middle of the Cold War, the nuclear arms race. We have to get to the moon first because we have to show other countries that we can get there. We can put base missiles there to destroy them before they can destroy us. A president had to die for this to be true. And his successor, Lyndon Johnson, happened to be the senator from the state where 95% of the space industry was concentrated. So he had a huge pork barrel incentive to go to the moon. Kennedy was a martyr to the moon missions. And today, almost anything either party proposes, think of any big plan. The wall on the southern border from the Trump administration, the infrastructure investment plan from the Biden administration. As soon as anybody proposes anything that costs more than a Happy Meal at McDonald's, the other group starts screaming. Horrible, bad, evil, wrong, wasteful, stupid, you know, and the shouting. And there are plenty of people in this adversarial government system who are ready to win their spurs by shooting down the other team's proposal. A government in a democratic country is not getting to Mars. I don't know. I put it's less than 50-50. We even get back to the moon. It's been 50 years. We haven't gone. We haven't gotten out of low Earth orbit in 50 years. We scrapped the space shuttle before the next launch vehicle was ready. Oh, it'll only be a year or two. It's been a decade and a half. And we still don't have a launch vehicle. SpaceX says they can get people to the moon. I'm willing to bet that if we have a dictatorial country where they don't have to deal with the other party, they can get to Mars. We can have a private industry may get to Mars, but this time it won't be a political military decision. It's going to be an economic one. Economics will drive space exploration heretofore, and agencies like NASA, ESA, JAXA are going to fade into insignificance. Like the dinosaurs, their day has passed, and they too shall pass away. I think as long as there's in America, there'll probably be a NASA, but will they be at the forefront of space exploration like where they were in the heyday, the 60s and 70s, and even in the early 80s? I don't think so. I think when we get boots on the ground, please God, in my lifetime, the first scoop of soil and an Explore scientific microscope would settle this issue.
I'll donate the microscope.
There you go. I'll chip in for the ticket price to send it. You know, here you go. Literally, it's not that hard to detect bacteria. You can, with any inexpensive toy microscope, a child's microscope, and a slide and a drop of water, you can find bacteria in virtually any soil or any sample of ground material on this planet anywhere. Pick it. Doesn't matter. The life is omnipresent on the surface of the Earth. So if Mars, life did self-assemble, if life did form on Mars as it did on Earth, I don't believe Mars is sterile. I don't believe you could sterilize a whole planet. We know you can't dehydrate a whole planet. We proved that one wrong. And so I see all the opposition points to Dr. Levin's research fall one after the other, after the other, after the other. And the official line today is still, Mars is dead, always has been. There may have been life a billion years ago, but the planet was sterilized. I simply find that far too incredible. It's Occam's razor, isn't it? The simplest explanation is always true. Life was there and was decimated as the planet was desiccated. But the idea that you could sterilize every rock, every possible location and environment for biotic life and sterilize it, it wasn't like Mars dried overnight. And in extreme environments, evolutionary change ramps up, right? We talked about the idea of mosquitoes and DDT. You spray DDT on the swamps, you kill 99% of the mosquitoes. The 1% that comes back is going to be a nightmare.
Yeah.
So Mars went under an extraordinary evolutionary pressure cooker. Do I think that meant everything was sterilized? No, I think it takes a stellar catastrophe to sterilize a planet, and Mars hasn't had one. So I'm a good scientist. I can say I believe, but I'm also going to tell you that's not data. I believe Dr. Levin's data was fundamentally sound. That's not proof. The experiment, we've never done what good scientists do. Oh, you have a questionable result? I want to try it. I want to try it. The whole scientific community, because science is not a, arm in arm progress to a bright horizon like the old Better Living Through Chemistry commercials. That's bunk. Karl Popper said it best, science is a last man standing grudge match in a cage. Most scientists spend most of their careers engaged in destroying other people's hypotheses. It's the ones that survive the assault that get elevated. And frankly, people have spit and sneered at Dr. Levin's work, but no one has been back to do the experiment again. The only person who's ever repeated the experiment in any condition is Dr. Levin himself. And he got positive results. So we'll have to wait, Scott. We'll have to wait and see. So I'm hoping that our viewers can look over the data, do some research, decide what they think for themselves. Of course, we can have a whole club of people who'd agree that isn't science either. That's like saying 99% of scientists agree in man-made global warming or the Earth-centered solar system hypothesis. A majority of poll doesn't matter because poll opinions don't matter in science. Data does. And we need more data. And we've never gone to get any. We've never even tried, not in 45 years. And it's a disgrace. It's an experiment that needs to be redone. And, Edwin Hubble never got a Nobel for discovering the expanding universe because he died unexpectedly. First of all, they said, oh, astronomy is not defined as part of the natural sciences under the original Nobel grant. People like Einstein, Fred Zwicky, Robert Millikan, all campaigned and said, we must give this man a Nobel Prize. He's had the most significant discovery in astronomy ever since Galileo found out Copernicus was right. The whole cosmos is expanding. He died. They never gave him one because the rules say you have to be alive to get a Nobel. I'm hoping someday some boots land on the ground. I'm patriotic. I would like to see American boots land on the ground. I'd be just as happy if they were European or Chinese or Australian or South African. I don't care. If I need a translator to figure out what's being said, I don't care. I want boots on the ground. And when the boots on the ground, as I believe they will, show that Dr. Levin was correct, then the Nobel Committee needs to eat some crow and make some kind of a posthumous award for this man. The discovery of life off of this planet, the only things that compare with it are the expansion of the universe and Newton's theory of gravitation. I mean, these are earth-shattering developments in the history of science. And science, how many centuries went by where everybody said, Aristotle's right, Aristotle's right. He wasn't, he never was. Not in his lifetime, not in the 2.5 millennia after his lifetime. He was never right. Copernicus was right. Galileo was right. Newton was right. Hubble was right. And I believe Levin was right. And Levin and Straight and Vishniac deserve to be lionized the same way every school child knows about Newton. And you know, the only reason everybody knows the name Hubble is because they named a bloody telescope after him. If you ask people who's the Hubble telescope, what is the Hubble telescope named after? Most people could not tell you.
That's
So
probably
there we go,
true.
Scott.
That's probably true. But that's why we have these shows. So
That's right. Do we get any
exactly
fun
why
questions?
we have these programs. So
Are you-
discuss all these things. I think that you know, I mean, certainly this this issue with Levin is, you know, it's very compelling. It's controversial. Okay.
Makes a good detective story, doesn't it?
Yes, it does, and it really makes you wonder what's behind the scenes. You know, how you know, because science is supposed to be about some friction, right? I mean,
Oh, yes.
that's how we, you know, and debate and all the rest of this. But it seems like a crime when it seems that you know, we want to smother out any other kind of you know, finding, especially after it was vetted so, you know, it was vetted so scrupulously.
The number of
and
people who've been ostracized and discriminated against and excluded because their results were not palatable is a very, very long one. Galileo is perhaps the most famous, convicted of heresy, imprisoned for the rest of his life. He's not the only one.
Ritchie was, you know, who built the 60-inch at Mount Wilson.
Absolutely.
It started on the 100-inch. You know, he's another one. You know,
There's another one.
right?
Einstein, of course, had to flee Germany, and all the anti-Jewish hate that was heaped on him by the Nazis. And he left, and many other scientists left. Fermi left. Heisenberg famously stayed. But he wasn't Jewish either. And many, many, many people. Darwin to this day gets attacked for saying things he never said. People come from monkeys. He never discusses this, never once. He was a great humanitarian, Darwin was, who abhorred slavery. If you read the Voyage of the Beagle, A Journey Around the World, he talks about being absolutely disgusted by the Spanish colonial government and their institutions of slavery and how degrading and dehumanizing it was. And many times, and he was a great humanitarian, he was a brilliant scientist, and people attack him because there are people in religious groups who thrive on setting up a false controversy between science and religion. There's no controversy between science and religion. Science people want to know how, religious people want to know who. Einstein had it right. I want to know God's thoughts. All the rest are details. Anyway, next week, friends, we're going to give everybody a great clinic on how to sketch Saturn and how to document the rings. With sketching, we're going to use my box and rectangle method. So we're going to go away from the theoretical. We're going to go back to the practical. And Saturn is just past opposition. And frankly, it has a 29-year orbit. So, and it's 10 AU away. So opposition or not, the view doesn't change very much, but it's in a great position for observing right now.
Yes.
And a lot of people like to try to capture it with photography, which is expensive and cumbersome and lots of hours at the computer. we're going to go back to an old school method everyone with a telescope can enjoy. And it doesn't require a big monster instrument. That's sketching at the eyepiece. We're going to teach you how to document Saturn, find and identify the moons using the box and rectangle method that I developed for my own astronomy classes more than 30 years ago. And I think everybody's going to enjoy that. And I'm hoping that after we do next week's program, people are going to email us and send us some sketches that they did of Saturn, because it's really an exciting, it's something you can do. It doesn't require a lot of artistic talent, promise, and I think everybody's going to enjoy it.
That's great. That's great. Well, that concludes today's program on How Do You Know? I do want to remind everybody that we have, tomorrow night, we do have the 59th Global Star Party. The theme is Ringed Planets. And we have, on the 25th, we have lots of programming that will be happening, including Tom and Linda Spilker from the Jet Propulsion Laboratory. Both of them worked on the Voyager mission when Carl Sagan was there. Linda went off to work on as one of the principal scientists on the Cassini mission, and then she made a full circle and came back to the Voyager mission, which is still flying after 40 years. I think this is the 44th year of the Voyager 1 and Voyager 2. They're out past the influence of the solar system, out past the heliopause. They discovered the Great Hydrogen Wall, and they are flying in interstellar space, and we're still getting data. There's still live, missions that are going on. So they'll run them until the fuel runs out and they can no longer be communicated with. So that is very exciting. This will be a historic and exciting program. I hope you watch that. That will be on Explore Now on the 25th, on Wednesday. And I think that we haven't pinned down the time yet, so you'll have to watch our calendar to get the exact time, but I believe it will be at 4 p.m. Central. And then we have 7 Months of Science that evening with Caitlin Ahrens. And in between those two, we have Cameron Gillis's Camstronomy. So you'll want to be with us on Wednesday. So we got a couple of days of fairly heavy programming going on. But this particular program, Daniel, was a great way to kick off the week. So, maybe get you guys to research Dr. Levin, buy the book on Amazon, and think about how his experiments might have absolutely worked, or maybe you find something that where you could poke a hole in his experiments. But that is what science is all about, and we'll learn more about the scientific method in the next How Do You Know? So, all right. So in the meantime, keep looking up, and we'll see you tomorrow. Take care.
Bye, everybody.